experiment is calibration of 3-phase watt-hour meter. The objectives are: understand the structure and principle of inductive 3-phase watt-hour meter, and 2, master the usage of inductive 3-phase watt-hour meter. So these two are the objective of this experiment. So let's see the experimental equipment. We have the control panel, incandescent lamp, 3-phase switch, data meter 1, watt-hour meter 1, and connection wires. Okay, so let's see the principle of 3-phase watt-hour meter. 3-phase watt-hour meter is based on a single-phase watt-hour meter, which is composed of driving element, rotating element, brake element, as well as register. The difference between the 3-phase and single-phase watt-hour meter is that every 3-phase watt-hour meter has 2 or 3 groups of driving elements, which will place an electromagnetic force on the same rotating element, and the 3-phase consumptions of will be shown by one register. All of the components are in the same containment. Therefore, 3-phase watt-hour meter has all the basic property of single-phase watt-hour meter. So when you talk about the 3-phase watt meter, it has all the property of what? Single-phase watt-hour meter. For difference among the groups of driving elements, every 3-phase watt-hour meter has its own special performance. So they have the same property, but when you talk about the 3-phase watt-hour meter, they have a driving element which make them special performance. So now 3-phase watt-hour meter is classified into 3-phase 3-element electric power meter and 3-phase binary element electric power meter. So these are the classification of 3-phase watt-hour meter. So the former has 3 groups of driving elements in one rotating mechanism, which probably is 3 double turntable, single turntable, or single turntable, and the latter also has 2 groups of driving elements in one rotating mechanism, which probably is double or single turntable. Considering the EMI, electromagnetic interference, among the elements, the electric power meter in a single turntable should take some measures to reduce the interference. So the interference in the meter, which is the single turntable, responsible to what? To reduce the interference. So the function of the single turntable is what? Is to reduce the interference of the meter. There is a close relationship between the error of the meter and the location and working situation of the element. The drive torque of because 3-phase watt-hour meter equals to the sum of the drive torque of all the elements. The number of the factors influencing the load characteristics of 3-phase watt-hour meter is much larger than that of single-phase watt-hour meter. So you should take note on that. So the number of the factors influencing the load characteristics of three-phase watt ammeter is much larger than that of a single-phase watt ammeter, and they are also more complex. Besides the adjusting device, every group of the driving element of three-phase watt ammeter adds balanced adjustment device to adjust the drive torque of all elements, just as single-phase watt ammeter has, which could help reduce the errors and the unbalanced load. In addition, three-phase watt ammeter also takes some effective measures to avoid the interference among the elements. So, connection principle of an three-phase watt ammeter. So this is the wiring diagram of what the three-phase watt ammeter. So let's analyze the diagram. So when you look at here, we have what? A, that's the phase AA, phase B, phase C, and the neutral. So we look at the whole thing big here, which is numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All what is here is what? Is the meter. So what we have seen here is the three-phase watt. So the phase A goes to the meter, which is the endpoint 1. Then it exits at endpoint 3, which goes to the 1 lamp. Then the phase B, after pass through the switch, it goes to the endpoint 4 and output from endpoint 6 to the load. That's the second load. Then the phase C, which pass through the switch, then it goes to the endpoint 7 of the meter. Then it exits from the endpoint 9 of the meter to the third lamp, which is the load. So now each phase is what? Is taking one load. Then with the neutral here, so the neutral goes to the endpoint 10 of the meter. Then we tap it from the same endpoint 10 to the load. Then what we share the neutral, since the neutral is common, what we loop it. So this is the overview of the wiring diagram of three-phase watt ammeter. So now let's go to the panel and see the connection. Okay, so this experiment we are going to use what? Three-phase induction watt ammeter. So the previous one was what? The single-phase induction watt ammeter. So this was the three-phase induction watt ammeter. So it's three-phase meter. We are going to set the phase to each lamp. So the single phase, we join all the lamps together, then we give it to the meter. But this one, since it's a three-phase, we are going to share the phase to each lamp. So let's see the connection. Okay, so now, this experiment was a three-phase induction watt ammeter. So we are going to utilize all the phases. So we look at it, you have a yellow phase, green phase, and red phase. So when you come to the meter, you have what? Yellow phase, green phase, and red phase. So it means that we are going to use all the phases to the meter. So the yellow phase will go to yellow phase, the green phase will go to the green phase, the red phase will go to the red phase. So that's what we are going to use. Then after that, we supply to the load. So let's see. Okay, so now I'm holding the red cable. So I'll put it here. I will set it this side. Then the output of this goes 1 load. Then I will take the green one. I'll do the green one also. So I'll pick it from here to the input. I take from here the output. Then it goes to what? To 1 load. Then to the yellow one. I'll pick it from here. Then to this side. From here to this side. So you see that what we have shared the faces to each lamp. So the yellow one take 1, the green also take 1, and the red one take 1. Okay. So let's do the neutral connection. So the neutral, I'll take it from here. Then I'll give it to the neutral. So you see that the neutral is only one hole here. So we go the neutral is common. So you go to share the neutral to the lamps. So I'll tap it from here. I'll give it to this one. So take note, the neutral is common, so we can share it to the lamps. Okay. Yeah, so we are done. So before we proceed to power, we need to check the continuity. For the safety reason, we need to check the continuity before we power it. So I will check the red face. So I'll put 1 here, and I will check all the red face. So you see that it doesn't have any connection with the other face. So you see, okay, let's go ahead to energize it. Put it on. So you see, we're going to introduce there. So I've introduced the 1 load. So you see that it was moving. So once I've introduced the 1 load, you see that it's moving was slowly. So I'm going to apply all the loads to it. So it's moving slowly. So I'm introduce all the loads. So as you can see, it carried that it's moving faster. So you see that it's moving. You see that the consumption of the 3 incandescent lamp is equivalent to using the single phase meter, because more load, as you apply more load, the same energy that you consume by using a single phase meter. Despite the advantage of using the single 3-phase meter, that when one phase is off, you can use the other phases. So you see that when the one phase is off, so look at when the one phase is off, the other phases are working. And also we use the 3-phase meter for 3-phase load and the higher consumption equipment. In conclusion, master the usage of it and be able to measure the consumed electric power by power meter under the condition if no watt hour meter is not available. So we should be doing that. So this is the summary of the experiment.